pretty much sleeping, but you never know. Can you hear us?
Brilliant.
Waved that to start.
Anyone else? Know it?
Oh, yeah.
Yeah.
Please. Thank you.
Yeah, no, this is like relaxing.
COVID.
And
it's
if
not,
you,
I
and
promise.
If you just got off the plane, it's probably you're all dried out.
It's on. It's on.
Hard. Okay.
Yes. Okay. Well, let's begin then. Welcome all. Welcome all. So I will be your moderator today, Rick Ziegler with UL Solutions. But first, to make sure we're in the right place, this is our Standards Pavilion, and the title is Built Environment Resilience, Addressing Climate Hazards in Fire Safety and Energy Systems. Welcome again. So we have about 1 hour. We might end a little bit before that, so maybe we'll call it 55 minutes. Again, my name is Rick. We'll kick off the event. We'll do a brief round of introductions, and then we'll get into some set panel questions. We'll pivot from the set panel questions and move into audience questions after that. So you'll have a chance to tee up your own questions to our panelists. But that'll come a little bit later. First, let me say just a bit more about myself. You'll see 3 ULs up here. I am with UL Solutions, an applied safety science company. And we have ULRI and ULSE up here as well. I'm going to let them introduce themselves. Again, my name is Rick Ziegler. I'm originally a hydrologic engineer and then worked at the U.S. Environment Ministry for 17 years. Now I've been with UL Solutions for roughly 3 years as the head of trade and multilateral affairs. That's me. And now what I'll do is hand it over one at a time, and we'll cycle through our panelists for their introduction, maybe 2 or 3 minutes for each. Let me start with, first on my list, is Caitlin D'Onofrio, our Senior Standards Program Manager, Sustainability, UL Standards and Engagement. Caitlin, may I hand it over to you?
Yes, thanks, Rick. So again, Caitlin D'Onofrio from UL Standards and Engagement. I am our newest program manager for sustainability, which is our newest industry program focusing on sustainability standards. And currently I am working on a sustainability standard for climate risk adaptation and risk mitigation, looking at the product type level, not just so much on the climate change itself, is how the product level of our current UL portfolio will perform in a climate weather event, focusing on the electrification products like solar, wind, and energy storage systems. Pass it back.
Thanks, Caitlin. And next, Adam Stingemore, please. Our Chief Development Officer, Standards Australia.
Thank you, Rick. Mahaba and good morning, everyone. As Rick said, I work for Standards Australia, Australia's national standards body. I have been around climate change, risk, adaptation, mitigation, resilience for about 15 years. I was one of the team that in Australia wrote a risk-based standard based on the ISO 31000 risk management standards for climate change adaptation for settlements and infrastructure. If I go back to when we did that 15 years ago, the world was much simpler. Much simpler. And we've seen a lot of change. We've seen a lot of change in the environment, in the impacts that we're facing in our country. A lot more wind, crazy storms, storm surge, and we've also decentralised our energy grid, which has a lot of opportunity, but has also led to new things that we need to manage. And Rick, it's wonderful to be here on the panel. Thank you.
Thank you. All right, next, let's turn over to Stuart Miller, Vice President and Executive Director, UL Research Institutes.
Hey, so good morning, everyone. My name is Stuart. So I come from the Research Institutes, and I'm going to tell you a secret about me. I have zero background in standards. I look at the accelerated design of materials for climate resiliency. The reason that I'm here and the reason that I engage with our colleagues and our friends in standards and engagement is that conduit between the design of materials so that we can design meaningful solutions to the problems that the world faces, it's so critical to have a voice with our standards, our friends in standards, so that we can actually move towards a meaningful solution. During my career, I've been with UL for 2 years now. During my career, I've been designing and commercializing materials for very large SP 500 companies. So the putting materials into the marketplace and also applying for certifications is not new for me, but working for a company that really embraces and leads in the standards arena is new. So being that voice, being that partnership is critically important to me. Does everybody can hear me? Okay. Thank you.
All right. Thank you. And last but not least, Judy Zakreski, Senior Vice President, Global Operations and Solutions with International Code Council. Please.
Thank you, Rick, and thanks to the Standards Pavilion for welcoming me here onto this panel today. The International Code Council is an NGO that's based in the United States but working globally. We develop model codes and standards related to building safety. The United States doesn't have a national building code. It doesn't have a national construction ministry, and it's a state function. And so we facilitate a process that develops a building code that's used across the country, and it's a model code with a lot of flexibility. And we've seen uptake from other countries around the world in using our building code so that countries are not starting from ground zero or from scratch and developing their own code. The code itself references about 1,500 standards that explain how to do what the code aspires to have done to create resilient and sustainable buildings. I've been at ICC for 6 years, and my background is not in building codes, it's in international business. So my role at ICC is to work with governments around the world to use the solutions available from ICC, which include the codes as well as conformity assessment solutions, training, credentialing for individuals, and accreditation to improve their built environment. And so we've been talking a lot about capacity building and ensuring that the ecosystem exists to implement a building code. When a country is thinking about a building code, we want to make sure that the building code is right sized, that the standards are appropriate, and that there's the capacity to enforce it. Otherwise, you don't get resilient buildings. You don't get sustainable buildings. And so we have a lot of focus on resilience to climate change, as well as other hazards and disasters, and the ability to actually enforce a code and standards that are adopted in a country.
Thank you. Excellent. Well, you can see we have a crack team. Now we're gonna dive into the questions that we have. Some preset questions. These are zingers, so we'll see how it unfolds. It'll be a little bit random, as I maybe would call on someone just to get it going, but we might not. Each panelist might not address each question, though we could. We have about 30 minutes for this, maybe 35 minutes. And about 5 set questions, but it might evolve organically. So I'm looking forward to that. So I'll begin, and because of the order of the introductions, Judy, I'll look to you first for this one. Our first question is, in your opinion, what are the biggest risks and vulnerabilities facing the built environment and infrastructure, especially energy systems, in view of climate change?
I would say that the biggest challenge for the built environment is the future uncertainty with climate change. Building officials, people who enforce building codes, people who develop building codes, like a lot of certainty. If you look at a building code, you see maps, wind maps, flood maps, and by and large, around the world, no matter what kind of code you have, no matter what kind of system you have, the codes are mostly based on historical information. But we know, looking at our world, looking at the climate, historical information is not a predictor of what a building is going to face in its serviceable life. So buildings built today will be functioning and in use in 50 to 100 years. And so they need to be built with the climate of 50 to 100 years in mind. And so we have the climate science, but it doesn't fit neatly into building science. And then you have the problem of not wanting to over-engineer a building, because then it becomes very costly. But you do want to engineer to a degree to prepare for future climate, because it is a lot easier to build a resilient building now than to rebuild or repair in the future. So I think it's this future uncertainty that, and the needle keeps moving, right? Because we're not doing enough to mitigate.
That's the needle continuing to move. Almost sometimes the goalposts are moving in a sense as well, depending on the analogy.
Yeah.
Totally agreed. And I don't know if another panelist would like to jump in.
I can.
Sure.
So there's a couple of points that I would make on this. One of them really from a materials chemistry point of view, and this is why I like engaging with our colleagues. As we think about how we design materials, which are all around us in this building just now, and we think about how we design them just now, and Judy, your point is excellent. What's the climate going to be like in 30, 40, 50 years? Just now, one of the things that's very apparent is materials, the more synthetic materials that we use within a building environment, we have what's known as off-gassing. So you will get chemicals, they're known as VOCs, volatile organic compounds, and these pose a risk to health. These are materials that when you're in the building environment, your children are there, they're breathing them in. And these off-gassings are becoming more and more prevalent at higher temperatures associated with climate change, because historically we've not designed our materials to be able to deal with that. So partnering with those in standards and engagement gives us the insight that we need, not just to design the materials we need now, today, but also where we need to be in a warmer climate. The second thing, the majority of my commercial career, I split my career between academia and industry. And I worked for 12 years for Honeywell, and I deployed large-scale energy storage units. When we were doing that, looking at the what's involved to be able to do that, climate, looking at how we view the climate, things like the risk of flood, the materials that we choose. If the materials, again, how do they, if your temperature is at 40 degrees Celsius rather than 50 degrees, does it affect the overall performance, longevity? These are really key things that we need to understand from a design point of view at the very beginning. And that sets what we know as our should-haves and must-haves. So our material should perform, or must perform at this heat. It should perform maybe 10 degrees higher. These are really critical things, and this is why I think the interlay between the research institutes, the standards and engagements, and those that are actually doing the testing, inspection and certification is so unique and so important.
Can I just add one more, Rick, point to that? Because I very much agree with that point. But we also need to work with the communities where this infrastructure is going to be used. So yesterday there was a panel, and a dear colleague, Vimal, who I see at the back of the room, was talking about bringing into the process the communities who are going to be impacted or affected or be using this infrastructure. So to Stuart's point, I mean, if we're building in coastal areas, we're going to want infrastructure that's going to be able to deal with things like wind and storm surge and be very easy to build back. In a different way to that, which you'd sort of build in Manhattan in the US, right? There's going to be different quality of construction. But then if we're talking about things like fire safety or the safety of batteries, that's a universal piece, right? Because you don't want batteries catching fire and you don't want VOCs in any environment. And I think it's about being really smart in terms of the way that we're deploying this infrastructure, including through the standards.
Excellent. And Caitlin, now I could say, Caitlin,
I could add in.
And you might even start the next question because you've been quiet too long. So now.
Well, no, I'll add in. From my perspective right now, looking at these climate risks, especially on the built environment, and looking at a building or an energy storage system, is the difference between acute and chronic weather events. Is this a one-time event that's going to happen, or is this going to be a chronic event, X amount of time or X amount of times per year, and looking at the built environment in a different perspective? But also there's that cost. We deal with a lot of technical committee members from a various different industries and the balance technical committee, and a lot of them are manufacturers, and they're always looking at the cost. It's going to be very expensive to build a building or an energy storage system that is going to be resilient amongst everything. So that's where the climate risk analysis and mitigation procedure, and also a predictive model. I don't think we're there yet. Looking at the data, we have a lot of historical data that Judy mentioned earlier. It's what is going to come in 10, 15, 20 years. Climate change, I think a lot of people have seen it. I'm from Canada, so our winters are getting less cold, but we're getting a lot of freezing rain, and our infrastructure currently is not withstanding it. There's a lot of flooding in basements, a lot of electrical power lines that it's too heavy with the freezing rain that's shutting down. So it's very different areas are going to look at climate change very differently. So how do you get the perspective geographically and all the voices at the table for every geographic region? It's difficult, but that's why we're here. We're talking about it, and I think collaboration is going to be one of the key aspects of looking at other SDOs, looking to see what they're doing in different countries, working with different organizations like UL Research Institute, having some data, some research behind it, working with standards and testing and certification on UL Solutions side, for example, is what are you seeing firsthand by the manufacturers, what they need. So it's a very big collaborative spider web of many different conversations that need to happen so we could address it appropriately.
Great. Yeah, and one thing, and some of the other questions I think we'll get to this as well, but as we talk, the first thing our minds go to is warming. But in fact, there's just so many more variables at play. Precipitation patterns, saltwater flooding, humidity, and those kinds of variables as well. I think some of these other questions will give us a chance to get into that. And I love, Judy, where you were going with like scaling and peer learning, taking a code here that might, in one location that might then be used by another location, going back to the learning and the peer learning. Okay, so this next question. Can you provide examples of products or systems specifically designed to withstand climate-related events, such as extreme heat and wildfires? I would add in there maybe some precipitation issues as well. And how can standards and conformity assessments support? So, Caitlin, I think now I'll turn to you again to continue where you left off.
Yeah, definitely. So, in Canada, there was a big push that came from some of our Standards Council of Canada that looked to provide grants, to provide standards that are looking at these different climate change risks. And I just looked at Canadian type standards, but for example, is what Rick mentioned earlier, is the climate change that we're seeing a lot is, those additional floods, the additional snow loads. We're getting a lot of higher winds. So we actually went through a project several years ago that revised many of our standards that were related into the built environment that can withstand these. So we created optional additional testing for resilience and incorporated those into the standards as an optional item, but it also was a big hit with insurance companies. So with insurance companies, especially if you had above ground oil and gas tank, for example, you want to make sure that is resilient, that can withstand the additional climate changes that might occur externally to the environment, or even sometimes maybe for underground. We also did look at increased UV exposure, so our heats are getting more. But it's not just the one-time event, it's the chronic event that is happening with the increase of temperature, but we also get the variations, the ranges. So how does a product perform with, one day it's very cold, the next day it's very hot, and it's that fluctuation that really is hard on a product. It's hard to measure, but working with testing and certification bodies is like, what is possible? How can we test this? What should be the threshold? Is having that conversation, as well as there is a big push for a lot of industries looking at providing grants to have these standards, but a lot of times policy and regulations are looking for standards bodies to have this included in our documents so they could point to it. But if we don't have it included, then they don't point to it, and then they're not used as much. So I think it's a lot, and I think it's just starting that conversation and having that process involved of you need many voices at the table, not just one perspective, and many countries. I'll pass it back to you, Rick.
I
Or
would
anyone
say
else.
to anyone else in the panel, if you'd like to jump in, please.
I'll add something, if it's okay, about wildfires, which are an increased risk around the world. I mean, last year there were wildfires in Siberia, right? I mean, it's bananas, but we're seeing them all across the world. And we're talking about buildings, right? The buildings need to be designed, if they're in a wildfire area, to, I mean, probably there's no building that can truly withstand a wildfire unless it's an underground bunker or something. But to protect as much as possible a defensible space, as many non-combustible materials as possible. And so we actually have a wildfire code, the Wildland Urban Interface Code, and that specifies certain materials, and this is where I'll bring the conformity assessment piece in, that there needs to be a process to make sure that those materials perform the way that they're designed and spec'd out to perform, that they're installed properly, and that you're not causing any sort of side effects from poor installation. But there needs to be some sort of normative criteria against which these products are tested to make sure that they are going to perform the function that they're designed to do, especially in an area that has a higher risk.
Excellent.
And can I come back to my community engagement point, Rick, just building on Judy's comments. So in Australia, we have a bushfire code, a wildfire code. I don't think we have lost a house in circumstances where the house has been built to the code and it has been properly maintained and prepared for the fire. We've lost houses in bushfires where people store wood under the deck, or where people have gas bottles that they attach to the house. And so I think as we're talking about resilient infrastructure, there's a really important community engagement piece here that goes well beyond the sort of getting a construction certificate to making sure that the communities that we're working with understand how best to manage the risks as they face them.
And I'm taking a note now. At some point, I have to summarize things. This is another great point, and hopefully I can keep a few of these. Now, we don't all have to answer all questions, but Stuart,
I'm happy to. Maybe a little bit of a different point of view. And maybe I'm going to offend everybody in the room, so where angels fear to tread. I see standards traditionally as being a reactive situation. You're reacting to what's in the marketplace, you're making the world safer through things that have happened. What climate change has told us and where we need to be able to get to, reactivity is no longer an option. It's proactivity that needs to happen, which means, this is why I'm here, we need to actually have everybody at the table now to discuss, because you don't get the same product cycle time. There was a beautiful slide yesterday that was talking about the timeline for standardization. I took it as an innovation cycle, where as you go back for maybe about 100 years or so, gradually it's getting less and less time that you can innovate to be impactful. The only way that we can be successful at doing that is by bringing every voice to the table at the onset of the project, when the project begins. And it means when you look at materials for climate resilience, we can talk about thermal stresses in, Caitlin mentioned ice showers in Canada rather than snow. This has a huge effect on wind turbines, because you've then got additional weight on the blades because the ice sticks to the blades of wind turbines. But we can look at thermal stress, thermal expansion of materials, and bake in some resiliency factors from the material design point of view. So there's a lot that can be done from the really early TRLs, the technology readiness levels, through to commercialization of products, if you get the right voices at the table at the very beginning. And I think that's the biggest thing that we need to learn, that proactivity.
Excellent. And I'm going to thank you, and I'm going to jump to the next question. Unless there's anything else that need be said to round this one out, I'll jump on.
Go for it.
All right. Okay. So there's much discussion at COP on climate finance, including financing our global energy transition. How can the finance community incentivize homeowners and businesses to adopt climate resilient practices to accelerate the adoption. And we're crossing lines in a lot of between these questions and some of the other answers. I mean, what is the level of the community responsibility or education and that sort of thing, as I think Adam might have hinted at, not having logs under the deck, for example, in a fire-prone region. But in this case, sort of how can this finance community incentivize homeowners and businesses, I think goes in a little bit of a different direction, perhaps even government incentives, depending on where we want to take this. I think there's a lot of doors for discussion here. So who would like to start this one off? I won't send out any names. Or...
I'll start.
All right, Caitlin.
Just from the research that I've been doing and looking at this climate risk mitigation for products itself, is a lot of insurance companies. The finance savings of having these more stringent products, yes, they're probably going to be more expensive because it's going to be more expensive to manufacture, but the long-term savings for that type of investment, if you're putting, a big solar panels on your house or a solar farm, and you're ensuring that they're resilient to all these different climate changes, will lessen your insurance. So maybe the upfront financial cost might be higher, but it's the long-term savings, and it's also that peace of mind that knowing that the investment that you're spending on these, for example, solar panels, will withstand hopefully a long time of this prediction of 10, 15, 20, 25 years, depending on the life cycle of those solar panels, is those additional climate hazards, whether they be acute or chronic, and having that risk mitigation for your geographical location, and also periodic reviews. Part of what I'm building in there is, okay, after 5, 10 years, if there's X amount of weather events, a service technician should come out and evaluate the product, because this is future thinking. We don't know what the geographic climate change is going to be for a specific region. So it's also collecting that data. So part of that is being smarter. Yes, you need to have a lot more infrastructure at the beginning to ensure that you have these people going out collecting that data, but it's working smarter for the long term to at least voice and dictate what it should look like maybe in the future.
Excellent. Thank you.
Anyone else want to add?
I'll jump in, because when Caitlin started talking about insurance, I thought she was going to say what I'm thinking, but we have a different. It's not different.
Point.
It's complementary. When in these discussions at COP and really talking about resilience and climate finance, I tend to bundle the finance and insurance companies together, right? So there's something to be said for personal insurance, personal protection against future hazards or your own investment. But I think, especially on an individual scale, you're not going to get the banks necessarily to provide as much incentive as insurance companies. Because when we take out a mortgage, when we build a house or rent a house, a lot of times you need to have insurance. And so those insurance companies have a lot of power, actually, to say, if your house is not resilient, if you're going to decide not to build a resilient house, we're not going to insure it. If you're going to build your house in a floodplain, we're not going to insure it. And so that incentive or disincentive to have property insurance for what is most people's largest investment, I think is a tremendous incentive to do the right thing and to build right and to build for the future.
Yeah. Well,
if I could just add one more point, without meaning to rain on this insurance parade, I think insurance is a really good mechanism because you can price a delta. But what happens if you get to a point where there's no price incentive, or if the premium gets to a point where the owner of the asset is unable to insure? And I think that's a challenge, right? Because then you're seeing infrastructure and housing fall off cliffs. The most sustainable housing that we have in the world is a house that already exists, right? So we need to protect that, and that's where I think there's a role for states or sort of broader money to come in where there's a real challenge there, and help to adapt that existing infrastructure to be more climate resilient. And I think in some of the projects that we're working on in the Pacific in particular, not only in the Pacific, around the world, we see these amazing new communities springing up on the left-hand side of the road. And on the right-hand side of the road, there's this existing building stock that is just being left, where if you threw a few dollars at that, or did something with that, you might be able to sort of give it another 10 or 15 or 20 years. And I just think we shouldn't forget about what already exists.
Absolutely.
And if I might just interject with a question, going off the script a bit, in terms of the older existing materials, do we find that some of the existing materials, things that have been in circulation for a long time, are often maybe a higher quality sometimes? Is that not a thing? I'm just curious in what you're seeing.
Well, I mean, if I can reflect on my experience, so sometimes you will find really good quality structural design, but it needs to be modified to allow for sort of wind pressures. Okay. Or you might find a nice shell that might be subject to storm surge, but it's full of gyprock or plasterboard on the inside. So what do? You don't knock it down, you take out the plasterboard. You fix the pressurization internally of the building. Those sorts of things I think are just as important. Thinking about how you might be able to bring distributed energy systems to those existing stocks is just as important as being over here and building an integrated system. And I think sometimes even some of the big thinkers forget about the existing stock.
Sure.
And it's really important that we think about what already exists, because the cost of construction of that is zero.
Yeah. Thanks for letting me go wander a bit. Yeah.
But I wanted to add in too, it's also, in my opinion, it's a mindset shift, because a lot of people look at the bottom line, and instead of building for quality over quantity, a lot of places are building for quantity, not so much quality. So I feel some of the materials are made cheaper, things are more put together, slapped together, because people want the bottom line. And even for, buying a house, people look at the bottom line price. It's like, okay, no, this is the cheapest, this is the only thing I could afford, but it might not be built to so much quality. And going into the resilience part is people just want something sometimes fast. They're not thinking of the long-term future. I think a lot of these newer generations are looking for fast change. They're not staying in a home for 25, 35, or their entire lives. They're constantly moving, they're constantly switching. So I think it's a mindset shift that we need to start looking at, is looking at the quality versus the quantity, and really starting at the younger generations to really emphasize that is, build for quality. You want products that are gonna last. Washer and dryers are not even lasting 5 years. And the warranty is what, a year? My grandparents had a washer and dryer for 35 years, still running. So it's building for the quality that I think it's been missing the last 35, 40 years. So that's not 100% related to this, but I just wanted to add that in. So
seeing how those issues scale from a product to an actual a home or a building, or a larger building, I mean, it's interesting as that issue of reuse or durable and quality infrastructure. Any other follow-on to this, or we can jump ahead?
We can jump ahead.
All right. We're moving on. Next question then. How are government policies influencing the development and adoption of climate-related performance standards for building materials and products? And for this one, I have a note here. Maybe start with Judy. So Judy, and you have the right to pass.
No,
or you can kick us off.
I'll accept.
All right.
So I think for performance-related standards, we're talking about what I mentioned before, that the product actually is performing the way that it was designed, that it's installed properly, that it's fit for purpose and used properly. I think that there are some incentives that we've seen. I don't know if we'll continue to see in the United States, but we have seen them with the Environmental Protection Agency offering grants to help manufacturers obtain environmental product declarations, so that particularly in Washington State and Oregon State, it's incentivizing the governments to request manufacturers to have environmental product declarations so they understand how sustainable the product is, what the carbon footprint is. The digital product passports that we're seeing, I'm going to just punt this off to you, right? The digital product passports that we're seeing in Europe that are really taking off, that's all data-based, and you need to have some kind of, again, normative testing criteria to make sure that the claims that are made in these environmental product declarations, life cycle analyses, that all of that, which leads into the digital product passports, is proper data, and that it's confirmed by an independent third party. We need a measurement to demonstrate the achievement of the criteria that's been set out. So I mentioned the EPA in Washington, Oregon. There are regulations governments can help to regulate to incentivize the use of performance criteria. We're seeing in the United States, again, not sure for how long, but the Department of Transportation, the General Services Administration, and FEMA all require EPDs now for concrete and asphalt for carbon measurement. And then governments can also influence the use of more sustainable materials through their procurement. Governments have huge purchasing power, and if they demand cleaner, more sustainable products, that incentivizes innovation. That incentivizes manufacturers to produce something if they know there's going to be a market for it.
Okay, one quick follow-up. Judy, I'll press just for a moment. How would it incentivize innovation? Could you give an example or two?
Sure. I won't point to a specific product, but if a government is saying, we're going to buy only low-carbon concrete, then traditional concrete manufacturers, they're not going to be able to sell their traditional concrete, right? There's going to have to be some innovation to create the low-carbon concrete, right? And so that if a manufacturer knows that they will have a market for low-carbon concrete because the government is requiring that, then it will incentivize them. Then they can put the money into it. Then they can do the research, and you know better than I do on this. But they'll do the research if they know there's a market.
Okay.
It makes the investment worthwhile because they know there's going to be a payoff.
We see the manufacturers then sort of compete with their innovation, the pace of their innovation, I would imagine. But I could be wrong, and I would open this up to others.
No, well, I guess I'll just add on to Judy's point, is even in Canada, that's a big push that the government of Canada does, is they put out RFPs, which is requests for products, and they call out specific EPAs or sustainability type standards that if you want to apply for this bid, that you have to have the sustainability initiatives or the EPAs or the life cycle assessments to even just get to that table. So they're really trying to incentivize putting out multiple grants, and I know, yes, there was a lot of grants coming out on the US side for EPDs, and just having that big push. Canada's still looking to do that. They're still putting it in the budget. I know with the recent maybe election for US, it might change a little bit, but it's also a lot of younger generations looking at sustainability initiatives and wanting to see those type of products that the government is pushing as well. But I'll pass it to you if you want to add.
Yeah, so I can certainly speak towards the funding opportunities for R&D. I think maybe if you sort of level set the conversation and we look at oil and gas. So the first oil refinery was opened in Pennsylvania in 1870. I spent a large part of my career working for oil and gas, and I believe that oil and gas have a critical role to play in the energy transition. As we look at from 1870 until 2020, you've got 170 years worth of innovation that's there. I have sat in projects, if you got a 0.1% improvement in yield or a half a degree reduction in temperature, this was a huge win because the revenue it generated by saving energy in the process was massive. If you look now at renewables, you can look at wind, solar, battery energy storage systems. You've got maybe 30 years worth of development. In 2022 and 2023, energy from renewables and storage was cheaper than it was from oil and gas. The Paris Accords at COP21 really set the ball to be able to say we need to change, we need to be able to invest in this infrastructure. And if you look at what's happened in the past 9 years, you've got a lot of funding that's available for research and development, because we've only got 30 years worth of development in sustainability, and already we've passed the price point of 170 years worth of innovation in oil and gas. So there's a lot to be hopeful for, but we need to make sure that our research dollars go to the right areas. And I don't think we should stop oil and gas now, because we've got to have a just, fair transition to clean energy. But I think we're moving in the right direction, and as long as we're putting the research dollars in the key areas, I think there's some really exciting things that will happen in the coming decades.
Can I just close it out, maybe with a slightly different perspective? So, picking up on the just transition point, I think in some countries and in some markets, the only standard that applies is price, and we need to work together to make sure that we can support a change there. That's my first point. My second point is, even if I use Australia as an example, right? Pretty soon we're going to need to be reporting Scope 3 emissions in our construction sector.
Yeah.
I'm going to quote a statistic and get it wrong, but I think 85% of those who work in our construction sector in Australia are small businesses. So if there is a guy who works with his family and they have a dump truck, that person's interest in looking at their Scope 3 emissions is zero. And so the question is, well, how do we support that person to be able to get involved in this global supply chain? If I think about some of our trading partners in the Pacific who want to join the global economy in a different way with different exports and things, how do we support them in joining this world of data following products and the circularity piece and all these things that we're talking about? And we really need to be focused on not just sort of leading from the top, because the top matters, but how do we bring everyone with us as we go through this? And hopefully out of this COP, we might find some things to do together to help everyone come along on this journey. As I've been around the pavilions, it seems to be a really common point that, yeah, we're moving here, but what about here? And I think that's something that we all need to be conscious of, including in the standards environment.
Absolutely. Great point. Well, we do have another question, panelists, but I think what I'd like to do is now, with where we are with the time, to open it up to audience questions, and maybe hit us with something that we have not had a chance to prepare for, to see where it goes. But I don't know if anyone had a question or if there would be anything online. Now, I do have more questions, so no worries if not. But if there is a question from the audience, now is the time. All right. Well, I'll move on to our next set question then. Not hearing anything from the audience. How are building codes and product standards evolving to incorporate climate adaptation measures? So if you have some examples, that would be great. And I open this to anyone who would like to jump in.
I guess I'll start. I've already mentioned that I'm working on a climate change adaptation risk assessment and looking at the product type level. Regarding building codes, standards and building codes, they really do come hand in hand, but the standards that we create can't dictate and, overstep on the building codes. So part of my next transition from a standards development perspective is, creating the standard and then going to the building codes and, advertising that we have, well, maybe not advertise, but voicing that we have this type of standard and to try to push it into the building codes. Because without a lot of times the building codes, then sometimes standards might not be used. A lot of these standards sometimes are optional. If they're not referenced in the building codes, it's up to the manufacturer wanting to spend more money to certify to these type of standards. So when they are in the building codes, it's a bigger incentive for them that they have to look at this. So that's kind of my journey that I will let you know how it is in 2025, but I'll open up to anyone else on this side of the house with standards.
In our codes, that we have the ICC facilitates the development of a suite of 15 building codes that are mostly, a lot of them are specialty codes, but we have a building code, a residential code, mechanical plumbing, fuel gas, that all fit together. But all 15 codes are updated on a 3-year cycle, so that there is this, and it's through an open process, so that anyone, including standards developers, can put forth their new standards, the new technologies, maybe even, we haven't seen this yet, but an approach to forward-looking building science in the codes. We actually just facilitate the process, so we don't, the ICC doesn't dictate what goes into a code. But anybody who's interested can submit a code change proposal, and it will be considered along with all of the others. But I think having an ongoing process where you're updating codes, and standards have this baked into the standardization process. Adopting a building code, we always say, is not when you declare victory, right? Not only do you have to make sure that it's enforceable and that you have the capacity and the talent and the infrastructure to make sure that it results in safer buildings, but you do have to continue to maintain it and update it on a regular cycle. The Australian Building Code is updated every 3 years, Canadian every 5 years. The states and countries that use our codes updated on varied cycles, but it is an important understanding that a building code is not a static document, it's living.
Right on. Interesting to think about how like code making could somehow outpace material innovation. Like that's really cool. I do wonder how our processes could be in place to do that, but I want to make sure the floor can continue to chime in if you want, or we can jump to another one.
Can I just make one point on this, Rick? I think as we go forward, we need to balance ambition with achievability and fatigue. A lot of industries and a lot of product manufacturers and land use planning people are fatigued, not by the ambitious change, but by the churn.
Yeah.
And I think we need to be really conscious as a community that we're setting targets and then we're helping people come along the way. And then my last point that I make often in a standard setting context is we need to also make sure we're engaging with and considering civil society as we go about our work. Not in the technical detail. I don't think civil society want to sit in our working group meetings, but they do have an interest in being involved in our processes.
Yeah.
Having input.
The only
input,
point
100%.
I'm sorry.
No.
The only point I would make is I think this is a really nice area for continued collaboration. The two problematic materials that I see from a research and development point of view are concrete and steel. And they're the largest global annual emitters of CO2.
Yeah.
And I'm sorry, but we don't have an answer for that just now. There's a few areas that are starting to look at green concrete and green steel, but humans are innovative. It's a problem that we will figure out. And in the next 5 to 10 years, this is something that will really boost, let's say, green buildings, being able to build buildings with concrete and steel that are CO2 negative. And I think that's an area that when we start to work and figure that out, having standards involved at the beginning is a really nice thing to have.
Okay. We have an audience question, please.
Do we
149.
need headphones? I can't
Pretty good.
sure.
Thanks so much. I'm a building scientist.
Oh, we need to.
Okay. No, I'm gonna talk loud. It's okay.
Oh,
Okay.
Thank you.
Thanks. I'm a building scientist based in Canada, so I know Canadian code, but I don't suppose you folks in Australia are building your buildings with Marmite, so it's probably gonna be the same question for everyone. It is clear that as we have regulated the building code, we have also made some mistakes, right? So for example, in Canada, the multiple egress for fire code was a mistake because we were doing it based on old construction materials and bad fire practices. And that caused a lot of housing issues because the amount of things that could be built were more limited. So my question is that, yeah, you are all talking about the standardization, and there is a whole other effort that needs to be done on deregulation. And I'm wondering what each of you folks have done in the last little while to deregulate one part of the code, and how has that been progressing for you?
Interesting.
Can I take that?
Yeah.
Because I actually take issue with the characterization of the two-stairway egress as a mistake. That's actually something that's being hotly debated right now in the US and Canada. And I was in Ottawa in September for a global meeting of building regulation authorities from around the world. And the Europeans, the people in New Zealand who have no regulation in this area, they were complaining about it. You know, the folks in New Zealand said, I wish we could implement two stairway.
I will hotly debate you on that. But also, I think like that's just one example. So think about other things. Like I'm in energy efficiency, and the way that we have regulated that is absolutely ridiculous because of the because of the software limitations we have created different wiring in the code to fix software issues. And there is a need for deregulation there at least. So my question is generally around, there are mistakes. So how do we fix them?
Yeah, I mean, I think if I can
you keep going.
Be less contentious in my response. I think that in an open development of a code or a standard, it's something that could be proposed, right? For instance, in the iCode process, someone could say, this regulation that you have in the code is no longer required. And then it really is, lobbying the governments to convince them that regulation is not required, because ultimately a model code, and this is different in each country, in Australia and Canada, pretty much the codes need to be used. The jurisdictions need to adopt them, but they're involved, right? So you need to convince the regulators. But I think they're generally more conservative because they're going to be thinking about life safety.
Yeah. And I guess I'll just add too is sometimes they don't know what they don't know. So having that voice and really advocating for something and approaching the standards developers, the codes themselves, like a lot of these are just volunteer members. So it's their time. And to be an advocate, if there's something wrong, speak up and encourage others to speak up, because the more voices people hear, the more willing that or faster that they could change things as well. So I'm always a big person of have a voice at the table, have a seat at the table, and that's how change really happens.
Can I just double down on your question? I think it's a really important point. Two things from Australia that I've seen. So I've seen chasing of energy efficiency in buildings, in closing the buildings up, and not thinking about ventilation of those buildings as a point perhaps right in your wheelhouse. And then more recently, I've seen in residential environments, people buying on the internet cheap electric bikes, plugging them in to charge them up, and then the bikes catching fire in their houses. This stuff is real. And that's not a standards issue, right? That's a societal issue. That's a public policy issue of the highest order that people need to grab right now. It's a really good question.
So I'm going to put my UL enterprise hat on. So we work as a power of three. We're one enterprise with three separate companies. And the reason I joined UL is because I believe they have the infrastructure to answer that question. So we have 5 research institutes. We have the Fire Safety Research Institute, Chemical Insights, the Electrochemical Safety, Digital Safety, and Materials Discovery. And we work hand in hand with our colleagues in UL Standards and Engagement. So when we look at the development of standards, we're actually bringing fire dynamics to, so we're not just developing standards because we want to develop standards, we're doing the research into it. We look at how does an EV burn in an underground system, in an underground car park. We look at how many egresses do you actually need from a house when you take away the walls and you have that more open floor plan. how much time do the residents have to be able to get out the house? So our standards are actually based from, we have a statement from our founder, William Henry Merrill, which is know by test and state the facts. When we have the organisation based with research coming from our research institutes, which is a different company from our standards and engagement, so that they can take it and they can know by test. And then we have a test and inspection and certification company that we do talk. You know, we're separate companies, but we do talk. I think that's a really powerful statement to be able to say, we're not putting standards out for standards' sake. We're trying to add value to society. We're trying to create impact. And I don't think it's a perfect situation yet, but I think we have an infrastructure that can begin to address that.
Really, really well said. And coming from UL Solutions, we're more focused on the testing and certification. Our engineers are, you know, during the testing and certification, our engineers take notes, and we do communicate with the Research Institute as well. So there are multiple feedback loops here, learning and then you know, learning from the past, what we see, learning from each other, in order to move towards those standards and then implement them. But I've digressed, and now we're at 1:57. But I think we have to round out. We have to move on. We've heard a lot of good discussion. I think I would invite the audience to think about cornering any of the panelists and asking more questions as we pass each other in these hallways. And to continue to learn from each other. I know for me, this was really impactful, and I already have some follow-up questions that I intend to track you down and see if I can't learn more on some of these topics. We talked a little bit about inclusivity, a just energy transition. I think that's very important, and I hope that we can continue the conversation there. I know there's many other sessions that will dive into that, and I've lost the moment to do much of a summary, but I would also go back to scaling, where we see one policy work. Judy, you mentioned this earlier, where we see a policy work. I think these exchanges are great for then sort of saying, wow, it worked there. Maybe we can promulgate it into this other region or with these other policymakers. If they've not thought about it yet, perhaps this is a time to educate them. And I think it's also interesting, the communities thing that Adam brought up, which is, and I took it to mean, where do the communities and the policymakers, where is there who's responsible for what, and how do we all work together? And I think that came up multiple times. I think Stuart as well. We talked about stakeholders involved and working together, being all at the table to solve these challenges in front of us. Well, that was my summary. We have 2 minutes left, and I think I was supposed to leave 2 minutes. So I appreciate everyone's time. And this was really great. Thank you.
Thank you.
Thank you, Rick.
Thanks, Rick.